Hello friends, in this video we are going to discuss about KNN algorithm. In machine learning, there are three types of machine learning algorithm. One is supervised machine learning algorithm, unsupervised machine learning algorithm, and reinforcement machine learning algorithm. Under supervised machine learning algorithm, we have two tasks. They are classification and regression. If your output data is a categorical data, then it is a classification algorithm. And if your output data is a numerical value, then it comes under regression. So under categorical data or under classification, we have many algorithms like KNN algorithm, decision tree, SVM, logistic regression, many more, under which we are going to discuss about this KNN algorithm here. What does KNN specify? K nearest neighbor. K specifies the number of nearest neighbor we are going to consider here. So K is the number of nearest neighbor. Okay, K, the number of nearest neighbor we are going to consider is K. So this KNN algorithm is not only used in classification, we can also use this KNN algorithm in regression also. But mostly KNN algorithm used in classification algorithm. So what is the specialty of this KNN algorithm is, it is going to consider the nearest neighbor, the similar nearest neighbor. Based on this nearest neighbor, we are going to assign the newly arrived data. For example, you consider this is a historical data, which means already available data. So this says about whether to give a loan to a particular person or not. For that, they have considered some of the features like customer name, age, income, and number of cards they have. And based on this information, they have also the output. This is a supervised, right? Supervised means we have the input as well as the output. So if the age is 35, income is 35,000, and if they have 3 credit cards, you can give the loan. And if the age is 22 and the income is 50,000, and if they have two cards, don't give the loan. So based on this historical data, when a new person comes with some information like his age is 37, his income is 50,000, and if he have two credit cards, now we have to decide whether can I give a loan to this particular person or not. So how will we decide that? Based on the already available data, we are going to find a similarity between this newly arrived data with the already available data, and who is more similar to this newly arrived data. And by seeing the similarity, we are going to decide whether I can give loan or not. So that is what the speciality of this KNN algorithm. We are going to find the K nearest neighbor, which means the K can be generally in an odd number, maybe 3 or 5 or 7 or 9. So I'll take some 5, maybe 5 if K is equal to, if I consider the K value as 3, then I'm going to find the K nearest neighbor of this David, who is more nearest neighbor means what, who is more similar to David, and based on their label we will be deciding whether to give loan to this David or not. Okay, so let us talk about some of the features of this KNN algorithm. KNN algorithm is generally said to be as lazy learning algorithm. Why? Because it does not learn anything during the training phase. Instead, it will memorize the training data. Okay, so because of this, we can seamlessly add many data as we want. So it will not take much time in training it. So we can uninterruptedly add more data as you have. So that is the lazy learning algorithm. Also, KNN algorithm is a non-parametric learning algorithm, which means here it doesn't do any assumption about the distribution of the data. So this is about KNN algorithm. Let me explain you with some more analogy. For example, you consider a new boy joined to a college. Now he want to find friends. So you consider there are 5 friends groups are there. So how he can make himself friend to any of the group? He will check the similarity of his character with the other group, or his taste with the other group. his hobbies with the other group. Like that, he will find the similarity with him and with the already available friend group, and who is more similar to him, to that group he will be joining. So similarly, KNN also going to find the similarity. So here, how does it find the similarity? Here is, it is going to use some distance formula. There are many distance formula is there: Euclidean distance, Manhattan distance. By that, it is going to calculate the distance, and that distance is going to give us the similarity, and who is close to the newly arrived data, and then based on that we are going to assign. Let's see an example. Here there are two classes of data. One is blue class and another one is red class. And here comes a new data. So now we want to decide whether this new data belongs to this blue class or to the red class. So what will we do? What are the steps to be done to classify this new array data? Let us discuss. So for that, in the KNN algorithm, first we have to decide the k value. How much nearest neighbor we are going to consider. As I said, you can take the odd numbers. So here we are going to take the 3 nearest neighbor. And the second step is, now to this newly arrived data, we are going to find the distance between all others. So this is a newly arrived data. Now we want to find the similarity between this data to other. Further, we are going to calculate the distance between this new data with the rest of all the data points in the data set. And after finding the distance between the newly arrived data with all others, we are going to find the order. You can use ascending order to sort it. So here, who is so close to it? This is D1, maybe the first value. This is next close one, D2. Then the next close one, D3. Likewise, we are going to sort the distance which we have calculated. To calculate the distance, there are many methods. Most generally used method to calculate the distance is Euclidean distance. Let us take an example to understand this formula. Let us consider there are 2 points are there. That is 1 comma 1. X-axis is 1, y value, x value is 1, y value is 1. And the next point and its value is 5 comma 4. Now I want to find the distance between these 2 points. According to this formula, how does we do? X1 minus y1, right? Or xi minus yi. So let us take this xi and this yi. So how will I do it? For example, 5, this 5 minus 1 the whole square, plus then the next value, this 4 minus 1 the whole square. So if you do it, you will get here 5 minus 1 is 4 square plus 3 square, which is equal to square root of 16 plus 9, which is equal to 25, and it is equal to 5. So now the distance between these 2 points is 5. Okay, so this is how we will be calculating the distance between 2 points using Euclidean. Similarly, we have other methods like Manhattan distance. So this is the formula for it. We are going to find the difference and we are going to take the absolute value and we are going to sum it up. In Minkowski sheets, this is the formula to calculate the distance. But the most generally used is Euclidean distance. By using the Euclidean distance, we can find the distance between newly arrived with the other and we have to sort it. After we sort, based on the k value, we have to take the neighbors. Here, we are going to take 3 neighbors. So who are the 3 neighbors near to the new point is this 3. So when you check here, the red point, that the red class, we have 2 data points under red, and in the blue class, when we consider the 3 neighbors, we have only 1. So who have the majority here? 2. So the newly arrived data will also belongs to this red class. So by taking the majority, we are going to assign the newly arrived data. So this is how we will be classifying the data in KNN by seeing the similarity. So to make it more understandable, let's solve some more problem. So here let us take, there are 2 data available. One is acid durability and the strength. And there we have the output classes as bad class and good class. So here this is the historical data. So now and we know the what is the output also. Now we are going to we are getting a new point, that is for x1 we are getting the value as 3 and x2 we are getting the value as 7. Now we want to classify whether this point belong to good class or to the bad class. So here there is no such data, right, to know the classification. So we want to find the similarity of this new point with the already available data, and who is so close to it, we have to decide. So what is the first step to do that? We have to, according to this steps, we want to decide the k value, right? So now here we are going to consider the k value here as 3. What is the second step we have to do? We want to compute the distance between the unlabeled data to all the labeled data. This is the unlabeled data, which means we don't know what is the output. What is labeled data? For all this data, we know what is the label, which means the output, good class or bad class, right? So now with this point, we want to find the distance. So now we are going to use the Euclidean distance. So according to the formula, let us do that. So how will we find the square root of this value 7 comma 7 with 3 comma 7? So how will we do? 7 minus 3 the whole square plus 7 minus 7 the whole square. So if you calculate, the answer for this is 4. Similarly, here for the next point, this point 3 comma 7 with 7 comma 4. So what is the value? 7 minus 3 the whole square plus this 4. 4 minus 4 minus 7 the whole square. If you calculate it, you will get the value as 5. Similarly, now we want to find the distance between this with this point 3 comma 4. So we will get square root of 3 minus 3 the whole square plus 4 minus 7 the whole square. You will get the value as 3. And then the last one, this 1 comma 4 with 3 comma 7. So 1 minus 3 the whole square plus 4 minus 7 the whole square. We will get the value as 3.6. So now we calculate the distance between this newly arrived data 3 comma 7 with 7 comma 7, 3 comma 7 with 7 comma 4, 3 comma 7 with 3 comma 4, 3 comma 7 with 1 comma 4, and we calculated the distance. So second step is over. What is the third step? Now we want to sort the distance in ascending order. So let us start sort it. So who will get the first rank? This is the first one. Ascending order. We are sorting in ascending order. This is the first one, and this is the second one, third one, and the fourth one. So we sorted it. What is the next step we have to do is get the top k values. Now here again we have considered the k value as 3, labeled data close to the unlabeled data. So out of 4, since the k value is 3, we are going to take the first 3 k values. So first 3 k values are what? 1, this one, and this one. For this 3 k values, we want to find the category to which it belongs to. So this value belongs to bad class. And this one, this class, this value belongs to good. Okay. And then this value again belongs to good. So now, since we have k value is 3, we have taken the k nearest value to the newly available data. Who are nearer to him? This one, and this one. So we have just seen the classes of it. So after here, we can see 2 classes are there, bad class and good class, or bad label and good label. In the bad label, there is only one data, and in the good label, there is 2 data. Now we can predict this newly arrived data 3 comma 7 belongs to good class because it only have the majority here. So now we have classified the newly arrived data belongs to good class. So this is how the KNN algorithm will be working, and we classify the newly arrived data to any of the categories. So it's a classification algorithm here. So what are the advantage of this KNN algorithm is there is no training period, right? As I said you, it is a lazy learning algorithm. It will not take learn anything during the training phase. So we can seamlessly add any number of data as there is no training phase. It is a much faster than other algorithms like SVM, linear regressions and all. And then since there is no training phase, we can add new data as much. Okay, and which will not impact the accuracy of the data. We can keep on adding data since it is not doing anything in the training period. And the KNN is very easy to implement also, because here we want only two parameters to be calculated. So one is we want to know what is the k value, and also next thing we want to calculate the distance. So it is very easy to implement. So these are the advantage of KNN algorithm. Let's discuss about the disadvantage of this KNN algorithm. This KNN algorithm does not work with large data. Why? Because see, when a new data comes, if the data set is very big, we want to calculate the distance between newly arrived data with all the already available data. If the data set is very large, calculating distance with the existing point with the already available data take much time and it is costlier. And it does not work well with high dimension data. So when there is many number of features are there, in that case also KNN algorithm doesn't work fine. And feature scaling, we need to do feature scaling here, like standardization and normalization before we apply for KNN algorithm. So if we don't do, then the KNN algorithms will not perform well. And the next one is KNN algorithm is so sensitive to the outliers and the missing data. So we have to manually fill all the missing values and we have to remove the outliers. So that is also a disadvantage of this KNN algorithm. So hope you got it. Now let us see a Python implementation of this KNN algorithm so that you will understand more clearly. So here to do this, what I have did is I have taken a data set. So first, before that, before we start, let us see what are the libraries I have used. I have used pandas to create a data frame from the CSV file. Then I have used this sklearn module. From that, I have imported test train split. What is the meaning of it? To the entire available data, I am going to divide my data into training data and testing data. And then I have this standard scalar so that I can bring all the data to a standard format or in a uniform range. Next one is I am going to take the predefined KNN algorithm from this sklearn, and then to evaluate this model, we are going to use this confusion matrix and the accuracy score. So now we are going to read the data and then we are going to implement it. So let's see that. So here the data set used here is this marks. Okay. Here I have taken the register numbers of the students who got the marks. So let me show the data set here. This is the data set where I have the register number of the students, what is their marks, and whether they have passed or not. So we here we have two classes. One means they have passed, zero means they have failed in the test. So here this is what the data set I am going to use to implement this KNN algorithm. So here I am going to read the data set and I'm going to consider the zeroth column as the index column. And then I have converted my CSV file to a data frame and I'm storing it in an object data set. After that, we are going to find the number of rows and columns in it. So let me run until this. Now let me first run this pandas library as well, and then I'm going to run it. So if you run it, you can see I have 60 rows and 2 columns are there. Because the first column, this column, no, this column I'm going to consider as the index column. So that is why it is going showing 2 columns. So which are the 2 columns it is going to consider is this mark column and the status column. So based on the mark, it's going to say whether the student got passed or failed. So that is what it is going to do. And now we are going to see the correlation between the features. So for that, this is the data set. So that for that, we are going to find the correlation between the variables. So here you can see the correlation between mark and mark, the correlation between the mark and status. So it is a positive correlation and that we can understand. So next one is we are going to clean the data. For that, we are going to remove the null values. So I'm going to use this drop NA, removing the null value. And after removing the null value, that update, I'm going to do it in the original data set itself. That is why we get in places root. So after I clean the data, I'm again checking the shape, which shows again the rows and columns. Same rows and columns I am getting, which means there is no null values in my data set. Next is I'm going to take the independent value and the dependent value. So what is the independent and dependent value? The input data is always called as independent variable. The output data is always called as dependent values, because this output variable is always depending on the input, right? Depending on the input only we get the output. Here what is depending upon the mark only, we can say whether the student got passed in the exam or not. So this mark is said to be as independent variable, and this output variable, now status, that is said to be as dependent variable. So we are going to take, so if you see in the data set, so here we have the register numbers, marks, and the status. So this mark alone need to be the input. So further what we are going to do is, from the data set using the slicing method, I'm going to take all the rows and I'm going to take the zeroth column alone, because this is the, I am considering this as the index. So this will not be taken here. So this is the zeroth column. So this mark column is a zeroth column. I am going to take this column in the X variable. So if you run it, we are going to take the all the rows and the 10 mm, 10 row value we are going to display it. So if I run it, you can see the 10 rows. Okay, the first 10 rows I am displaying here. This is the row, this specifies a row, and I'm taking the first 10 row values. Then I'm going to extract the y value. Y variable means dependent variable. So if you see here, who is the dependent variable? The status. This is the dependent variable. So whether the student got passed or failed. So which column I want to take for this? The column I want to take it. This is zeroth column and this is the first column. So here I have taken slice and take all the rows. In that column is the first column. And in that we are going to display the first 10 values. So here you can see the first 10 values. In the first 10 values, there is only one student got failed. So if you see in our data set, in the first 10 values, there is only one student got failed. So just we are displaying our data set. After that, what we are going to do is, we are going to split our data set into training and testing. So we have already imported this class train test split, which help us to divide our data into training data and testing data. So further, we are going to give this input and output variable. So this is the independent variable. This is the dependent variable. So both the things we have given, and we are going to divide it into 75% we are going to take for training, and 25% we are going to take for testing. So the test size I have mentioned is 25. So automatically for the training, it will take the 75% of the data. Random state I have taken as 0, so that you know that every time the same data will be taken. And here we got the 4 variables. So what does it specifies? In the X value, from the X value, I'm going to take 75% of data as a training data and 25% of data as a testing. And in the Y variable also, that is the status, whether the student got passed or failed, there also I'm going to take 75% for the training, and in the test data Y variable, we are going to take 25% of the data as the test data. So from this data set, we have taken some, we have divided into 75 and 25. So we can run this as well, so that we can divide our data. So I'm going to run this. So when I run it, we got it, and you can see in the variable, you can see the X test data. This is the X test data. That is test data we have 25%, and in the training data we have 75%, as well as in the Y test, you can see the status alone coming here. Y test, it will contain 25%, and in the Y train we have 75% of data taken here for training. Now we are going to standardize our data, the X training data and the X test data. So standardize means, if you see in our data set, the marks are ranging from 0 to 40, and the status is only 1 and 0. So what we are going to do is, we are going to standardize and we are going to bring it between -1 to +1. So for that, so that it will be easy for the computation. So, and it will take less time to do that. So for that, we are going to do the feature scaling using standard scaler. So now if you test, see the, so here we have given the input x train and x test as a input, and we have standardized the data. So after you do the standardization, and then we are going to use the already available k nearest classification, KNN algorithm, which is already defined in sklearn. We are going to use it. And now the important thing is, as we saw now, we have to mention number of k value we are going to consider. Here the k value, the nearest neighbor we are going to consider is 5. After doing that, we are going to execute it using the fit function. So for the training, we are going to pass the training data, that is in independent variable and the dependent variable. So both of this we are going to give, and we are going to train it, and we are going to generate a model. That model we are going to keep it in KNN. This is the object of this one, and we are training this data using this. And now this KNN is the object which contains this function, and that we are going to fit you for this X train and the Y train data. After that, we are going to predict for the test. Now 75% of the data got trained. So, and we got the model, right? Now we have to we have to test this model, this KNN. KNN is a variable where we have stored the model. So this KNN, we want to, using this model, we want to test it using the test data. So already we have taken some data for testing, right? So we are going to give this data, and we are going to check how the KNN is giving us the output. Actual output for this X test is present in the Y test, but we are asking the KNN to predict the value for this X test. That we are going to keep it in Y predict. The actual value is where in Y test. For this X test, that is for the input data, what is the actual output is present in Y test. But we are going to ask the model to predict it, and we are going to keep it in the variable Y predict. So we got the model, the KNN model is now predicting and giving the Y value. Now we are going to display this both value, the actual value and the predicted value. First one is the predicted value. See, first one we are displaying the predicted value. Then Y test is the actual value. See here, Y test is the actual value we got from the data set. So when you compare this both, you can see how well it has predicted our output. So wait a minute. We run it once again. So now you can see this is the predicted value 1, and the actual value is also 1. Here all are same. Here only you can see, this is the predicted value is 1, but the actual value is 0. Here it do the prediction wrongly. And here also it is doing the wrong thing. Actual value is 0, but it is predicting as 1. The first one is the predicted value. Second one is the actual value. This is the actual value, and this is the predicted value. Actual value is 0, but it is predicting as 1. Here it is actual value is 1. The predicted value is also 1. So this shows the comparison between the predicted value and the actual value. Now we are going to evaluate the model. So using the confusion matrix, we are going to give the actual value and the predicted value. The difference between the actual value and the predicted value will help us to know the error. So that two are given as an input to the confusion matrix, and we are going to print the confusion matrix. This is which is available in this variable, and also we are going to check the accuracy of the model. So accuracy of the model, for that also we have a predefined function already available in sklearn. And for that also we are going to give the actual value. This is the actual value. This is the predicted value by our model, that is the KNN. And let me run this. Okay. So what is what we can understand out of it? See, this shows the confusion matrix. This is the true positive value, and this is the true negative value. What is the meaning of it? For the zero class, see, this is the zero class. This, 25% of data is only taken for testing, right? So in out of it, how many zero class are there? 1, 2, and 3. Out of this three data, only one is correctly classified. Which one is correctly classified? Here you see, this is 0, and the predicted value is also 0. And but here this is 0, but the predicted value is 1. So here 1 went wrong. And here also 1 vendor. Actual value is 0 and the predicted value here we are getting is 1. So you can see out of 3 0 classes, 1 is predicted correctly and 2 is wrongly predicted. And then when you come to the 1 class, this specifies about the 1 class, which means 1 specifies the past students, 0 specify the failed student. So in 1 class, all the classes are correctly classified. See, these are all 1. Predicted value is also 1. Here also, all 3 are 1. The predicted value is also giving us 1. Here also, all the past classes are correctly classified. So, this is the true negative value, which means 12 values are there in one class. In all the 12 are correctly classified. There is 0 wrongly classified data. So, the accuracy of our model is 86%. So using the k-nearest algorithm, we got this accuracy for this data about the students' marks. Now what you can do, you can check for different k values, give different k values. You can change the k value as 3, as 7, as 9, and by for different k values, you can check what is the accuracy you are getting. Also, you can change this also. You take 20% of data for testing, 80% data for training. Take 60% data for training and 40% for testing. So that also you can take different training data and testing data, and with different k values also you can check different possible values and check the accuracy and choose the best one. So hope you got how KNN algorithm works, and also these are the implementations also. Hope you have got it, ma. Thank you. God bless you.